Hi, in this session we'll be doing percentages and we'll connect a lot of things that what we did in ratios. For example, we'll be using variations very heavily. So it's important that you know variations and you know how to use multiplying factors, okay? So percentages, this is the symbol. Most of us are very aware of this concept. We have always, at least everybody has knows their school mark compared in percentages, right? So what is a percent? First of all, it means percent, which is 100. So per 100, right? And in interpretation, it would be essentially percentage is just like ratios is also a relationship. Yeah, and unlike ratios, which could be a relationship between more than two numbers, percentage is a relationship between two numbers only. So whenever you see the percentage sign or the percentage symbol or hear the word percentage, you should know that it is going to connect two numbers. Any two numbers are going to be connected, where one of them is supposed to be 100 or considered equal to 100. Okay. Let's take a very simple example. Let's say out of a test of 25 marks, you've got 20 marks. Okay. And you want to convert this information into percentages so that you can compare it with your friends from other marking schemes as such. Okay, so the question is the relationship that exists between 20 and 25, that exists between some number and 100. Okay, what is that number? Yeah, so if I try and figure out x, I will take this 100 this side. Most of us again are already familiar with this form. We straight away do this. Our school marks, our marks divided by total marks into 100 is what we did in school to get our percentages, right? But this is the step before that. And once again, let me repeat what the connection is. That the relationship that exists between 20 and 25 also exists between another number and 100, 25 corresponding to 100, right? Is that okay? And if I work out the value of x, I will get 80%, right? So if you got 20 out of 25 marks, it is the same as saying that you got 80 out of 100 marks. I hope that relationship is very clear. They all, both of them reduce to the same thing, okay? This becomes 4 by 5 and this is also 4 by 5. So once again, repeat the idea in your head. Percentage is a relationship. It's a relationship between two numbers only. In this case, it was your marks divided by total marks. Yeah. And the percentage indicates that the relationship between these two numbers is the same as the relationship between some number and 100, and one of the numbers is always corresponding to 100. In fact, what number is corresponding to 100 is more often than not the bone of contention in percentage questions. If you understand this relationship with 100, more often than not the idea would be very clear. This, whatever number is equated to 100 is called the base. So working on a base, right? Okay. Okay, just repeating the same idea in different way. Let's say the question is 40 is what percentage of 50? Easy enough number. 40 is what percent of 50? So what you have to understand is the question is that the relationship that exists between 40 and 50, because they are already given, exists between what number and 100. Yeah, what number and 100? 100 corresponding to 50. Get the idea again in your head. When you have, it's a very simple question. Most of you would do it very easily. 40 is what percent of 50? What we are saying is 40 and 50 obviously have a relationship. The same relationship would exist between a number and 100, 100 being equal to 50. And the relationship I know is very easily expressed in this numerator-denominator ratio form. So 40 by 50 has the same relationship between as x and 100. This 100 I can move here. Once again, the answer is 80% only. Again, most of you would probably just do it directly, 40 by 50 into 100 and get to the point. But yeah, we want to get this view back Because this also tells us one more thing, that the percentage information is nothing but ratio information. And if we are okay with ratios, then handling percentage become even easier. Okay. Okay, even, I mean, easier question still, okay. Let's say find 40% of 750. Okay, what does this question mean? I'm sure most people know that straight away we can do 40 by 100 into 750 and we'll get our answer. But I want to come to this and slightly slowly. So 40%, right? So 40% means I already know that there is 40 and 100, okay? And the relationship between 40 and 100 is the same as, it says 40% of 750, right? So 750 is the base here. Why? Because the operator is working on this term. So I will put 750 in place of, in front of 100. And this is what I want to find. So I will get x is equal to 40 by 100 into 750 and I'll get my answer. Yeah. So nothing, basically instead of going there, I'm just going a step backwards. And once again, my point is also to see that this is percentage information, but it also looks a lot like ratios. This point will be elaborated further in a bit. Okay. So essentially, since percentage is about two numbers and one of them is considered to be 100. Now, which one is considered to be 100 is basically in our hands, or in basically it's a matter of convention that what are we talking about. Okay. For example, if I just take two plain numbers as 30 and 40, let's say. Okay. Now I know that percentage is the relationship between two numbers, but which one of them should I consider to be 100? Now it's totally up to me and how I express that information. Okay. For example, I can take B to be 100 and my language will be something like this. A is what percentage of B. This of B tells me that B is supposed to be 100. Okay. So when I do A by B, and when I try to equate it to another relationship which a percentage is, I will put 100 in front of B, right? Okay, and what percent? Because I do not know, so this becomes X. Now I know B is 40, I can put 40 here, and I know A is 30. Yeah, if I figure out the value of X, it becomes 30 by 40 into 100, which will give us 75%. Okay, I'm putting the percentage symbol there. Is that okay? So that means I can say A is 75% of B, right? Keeping B as the base, there is one more language option available to me to express not A is form, but how much is A less than B. A is what percentage less than B. So here, instead of it becomes less than. The base is still 100. The percentage operator is still working on B only, right? Now, A is what percent less than B. Forget the percentage symbol for a bit and say A is what less than B. Your answer would be A is 10 less than B, right? It is 10 short, okay? Now you have to express the same information in percentage. 10 is what percentage, we can't express it in absolute terms. In relationship with B, how much is it, as if it would connect to another number called 100. Okay, so 10 by 40, I have to calculate into 100. So basically I figure out that it's 25, this 10 by 10 is 25% of 40, or 10 and 40 have the same relationship that 25 and 100 have. So I can write here it's 25% less than B. There was another way of going about it. A is 75% of B, right? That means when B is 100, A is 75. And A is, how much short is it? 25 on a base of 100 straight away. So I could have come from directly here also, but right now we're just practicing our way back and forth in this relationship. Now this was focused as B on the base. I can rewrite the question and say B is what percentage of A. Now the focus is on A will be equal to 100, so I will write B by A. If I want to keep 100 in the denominator, I could have also done it, put 100 here and put A here, but basically 100 should be in front of A, wherever you want to put it. And I want to figure out the value of X. I know the values of B and A. B is 40, A is 30. I just have to rearrange it here. Yeah, and my answer would come out as 133%. Okay, that means if you think of A as 100, then B would be 133.33. If A is 30, then B is 40. When A is 100, B would be 133.33. That's what we get out of this. I could obviously rewrite this equation as B is what percentage more. Yeah, here it was off and less than, here it is off and more than, obviously because either the numbers will be equal or greater than and less than each other. So once you look at two numbers, you have basically 4 language methods of representing it. Okay, so I hope you take a couple of numbers and work on them and try and figure out these relationships back and forth in any way which you want to, but know very clearly that any of them could be taken as 100. It's completely under your control or the control of the question setter. Somebody would be telling you that this is the percentage, and language of, less than, of, more than would be present there. Okay. Okay, another very basic operation is increase and decrease. So let's say the price of an article is increased by 10%. Okay, what does that mean? P is increased, so I know it's going to be P plus something. Okay, but by how much is it increased? So whatever is the increment amount, it is saying it is 10%. That means when we look at 10%, we already know that there is a relationship between 10 and 100. The same relationship exists between the increment amount and P, right? So if I do it separately, the increment upon P is the same as 10 by 100, right? So the increment is 10 by 100 of P, and I know P is increased by 10%. I was going to ask for the new price. So P plus 10 by 100 of P. Yeah, obviously I could remove P here and say 50 is increased by 10%. So what is the new value? When 50 is increased by 10%, how much will you get? So if you just put 50 here, you will get your stuff. So answer would be 55. Yeah, I could do the same thing backwards. Let's say Z is decreased by 20%. Yeah, so Z minus, because there is a decreased here, Z minus, by how much? It would be decreased by some decrease amount. Okay, but what is that decrease amount? It says 20%. That means there is a relationship between 20 and 100. The same relationship exists between the decreased amount and Z, right? Actually the fuller statement would be Z is decreased by 20% of Z, but often this is not mentioned there. It is just assumed that we're talking about the same base here. So these value once again would be 20 by 100 of Z. Again, an operation that most people should be familiar with. So instead of D, I will write 20 by 100 of Z. Is that okay? So that would be new Z, Z1, the value has changed obviously. I could put 80 here and try and figure out the value. All things will just become 80. So this gets cancelled, and 80 minus 16, you get 64. Yeah, so this is basic increase and decrease. This is relevant because things can happen. Okay, so another key idea that we need to learn is the fraction percentage equivalence. Okay, for example, if you were to find 50% of a number, you would straight away now do 50 by 100 into the number. Yeah, you're supposed to find 50% of a number, 50 by 100 into the number. But if you look at this 50 by 100, the 0 0 can be eliminated, and this 5 by 10 can be rewritten as 1 by 2. So can I say that multiplying a number by 1 by 2 is the same as finding 50% of that number? Yeah. Similarly, let's say if you were to find 25% of 60, let's say, okay, 25 by 100 into 60 is what you would have done to find 25% of 60, but this 25 by 100 can be rewritten as 1 by 4. Okay, so once I notice this idea, what I can do is, some of my calculations can become faster, and not only that, we'll be able to form multiplying factors using this information, which we'll see in a minute. For example, in terms of calculation also, if I were to ask you to find 33.33% of 66, let's say, yeah. Now, if you think in your standard method, 33.33 by 100 into 66, you will start calculating, there will be some amount of trouble. But just like 1 by 2 is equal to 50% and 1 by 4 was equal to 25%, 1 by 3 is equal to 33.33%. So finding something, finding 33.33% of 66 is the same as multiplying it by 1 by 3, which is a far easier calculation compared to what we were doing earlier. So it is in our benefit to learn these reciprocals. The ideal table would be to do it from 1 by 2 to 1 by 30, right? It should not be too difficult to memorize this and maybe a couple of days of work at it will be required, but to whatever we are going to do now and now onwards, learning this or knowing this would be very, very integral, not only in working it out, but working it out very, very quickly. Okay. Okay, so let's use this reciprocal information now to get to the interesting part, the juicy part. We want to form multiplying factors. Okay, for example, once again, let's say P is increased by 10%. Okay, so standard method would be P plus 10 by 100 of P is equal to new P. Okay, we'll be dealing with abstracts here. But we've just seen at the reciprocal table, here also we can obviously see it getting cancelled, but it should be in your memory that 10% is nothing but 1 by 10. So we are writing this down here for learning right now, but we'll eliminate this step soon enough. So essentially, can I rewrite this or rethink this as P plus 1 by 10 is equal to P dash? Yeah. Now, basic fractions, P plus 1 by 10, the base would be 10, or to do it faster, you can think of this as 10 by 10. So overall it is becoming 11 by 10 P is equal to P dash. Okay, so once again take a look at it. 11 by 10 P, we said P is increased by 10% and we did the standard way, and it came down to multiplying it by 11 by 10. So multiplying it by 11 by 10 or increasing it by 10% is the same thing, and this is equal to P dash. Okay, let's look at a couple of more examples and master this process. Okay, let's say it was given that X is decreased by 16.66%. Okay, now I will still write the step in the next one. I won't. X is decreased. X minus 16.66 by 100 of X is equal to X dash. Okay. Now 16.66%. Now it will not be too easy to calculate, but if you have it in your memory, is nothing but 1 by 6. So X minus 1 by 6X is equal to X dash. Again, quickly, if you want to think, make it 6 by 6. 6 by 6X minus this becomes 5 by 6X is equal to X dash. Okay, so multiplying it by 5 by 6 is the same as reducing it by 16.66%. Yeah, I hope that idea is clear. In both of these ideas, if you notice, what I can also do is, basically the ratio form is not too far away. If I move this p dash here, and it will become 10 by 11 p upon p dash. Yeah, same for here, x upon x dash will become 6 by 5. Yeah, so basically in percentage information, ratio information is contained, or vice versa. We'll also see that in ratio information, percentage information is contained. Yeah. Let's look at one more jugglery involved here. Okay, the question could be: A is 75% of B. B is what percent of A? Okay. First of all, I hope you understand that the answer is not 75 for both of them. Here the base is B, in here the base is A. And this means when B is 100, A is 75. And this means, and the question here is, when A would be 100, how much would be B, right? Is that okay? So you have to think in that direction. But let's focus on this part. A is response to an equal to sign. 75%, you know the percentage equivalent for 25. 1 by 4 is 25%. So for 75% it would be 3 by 4, 3 times that. So A is 75%, 3, or you could have said 75 by 100 because we are starting out. And 7500 I can cancel out and it becomes 3 by 4. So this A is 75% of B should be visible to us as, first of all, in this form: A is equal to 3/4 of B. This is what we want to learn. If we can learn this, a lot of our calculations will become faster. And we don't want to write the whole thing. We want to start doing it in the head, and the steps would be 75%. The fraction for this would be 3 by 4. A is 3 by 4 of B. Is that okay? Now, but the question was, B is what percentage of A? That means B was supposed to be expressed in terms of A. I can do this very easily. I can take this 3 by 4 and move it this side. So it will become B is equal to 4 by 3 of A. Is that okay? Now herein, instead of explaining it further, I can try and convert this back into the percentage form. I know 1 by 3, if you look at the table, 1 by 3 is 33.33%. So 4 by 3 would be 133.33%. So my question straight away gets answered if I flip it. B is what percentage of A? B is 133.33% of A. Are we okay with that? Plus, in both of these forms, basically you have the ratio A by B is equal to 3 by 4. If you have the ratio, any percentage, remember we spoke about 4 possible language variations. If you have this ratio, you can work out all those language forms according to your needs. Okay. So B is what percentage of A? B is 133.33% of A here. Okay. Let's try one more example here. If I tell you that X is 110% of Y, I could have also written this as X is 10% more than Y. Okay, so X is 110% of Y, so X is 110. 10% is 1 by 10. 110 is 11 times that, so 11 by 10. Yeah, X is 11 by 10 of Y. So this information I got here, or I could have worked this: X is 10% more than Y, so Y plus 10 by 100 of Y, which would have become 1 by 10, which would have become 11 by 10 of Y eventually only. So same thing, because they mean the same thing also. Now if I want to convert it in terms of X, Y is what percentage of X, or Y is how much less than X, all I have to do is flip the multiplying factor here, and I get Y is equal to 10 by 11 X. If you are more comfortable, I can put the 10 by 11 on this side just for fun, because it's organized like that. So y is equal to 10 by 11 of x, and now start thinking 1 by 11, again you can refer back to your table right now, but eventually should be in your head and memory. 1 by 11 is 9.09%. So 10 into 9.09% would give you 90.09%, right? 90.9%. So y, your language form would be y is 90.9% of x. Is that okay? Or I could have said, okay, y is equal to 10 by 11x. Let's spend some time here interpreting this in the negative form. We got y is equal to 10 by 11x. Yeah. Now this means it is less than x, right? So y is equal to, I'm breaking the fraction here. It must be x minus 1 by 11 of x. Is that okay? Yeah, because it would if they were equal, it would have been 11 by 11. So think of this as 11 by 11. 11 by 11 minus 1 by 11 would give you 10 by 11. And this 11 by 11 becomes 1. So is y equal to x minus 1 by 11 of x, which would mean y is equal to becomes is, minus means less than x. Y is less than x, we know that, but y is how much percentage? Here we had 1 by 11, right? And we know 1 by 11 is 9.09. So y is less than x. Y is how much less than x? 9.09% less than x. Yeah. So I hope this idea, we are getting warmed up to it. But don't worry, we'll be using it a lot more. I mean, we'll practice this some more, and then we'll see it applied in a lot of questions. But this is the introduction to the idea. You have to take your time and learn this, learn the fraction percentage table also, and how to form it quickly and orally. We will see a lot of demonstrations for that. Okay. Okay, so if we try and summarize the process, a few things are happening. For example, if I say P is increased by 25%, okay? So now I want to do it straight away. 25% means 1 by 4, right? Now 1 by 4, it is increasing by 4, 1 by 4. Just assume this as 4 by 4, so your denominator will remain 4, and it is increasing by 1 by 4. So here it would have been a 4 by 4, but it is increasing by 1 by 4, so it is becoming 5 by 4. So this is equal to P dash. This is what we want to do without any errors and very, very quickly, because it's a very easy step. This means 1 by 4. Increase would mean 5 by 4, because it is 1 plus, your P plus 1/4 of P is getting added. You can see it back in your equation also, P plus 25 by 100 of P, which becomes 1/4. You do the same thing, you get here only, but you start doing it in your head. Okay, let's try a few more numbers here. P is increased by 6.66%, okay? I should know first of all that 6.66% is 1 by 15. P is increasing by 1 by 15. So put the 15 in the numerator. Think of P as 15 by 15 for a second in your head, and it is increasing by 1 by 15, so it is getting 16 by 15, right? So you're multiplying P by 16 by 15 is the same as increasing it by 6.66%, okay? Same, a couple of backward calculations, I mean for subtraction. Let's say Q is decreased by 15%, okay? Now for 15% you don't have a direct fraction, but you know 1 by 20 is 5%, and 15 is 3 times 5, so 15% would be 3 by 20. But here it is decreasing, so first of all you just write Q, put the denominator as 20 only. So if there was no change, Q would have been 20 by 20, but it is decreasing by 3 by 20, so this would become 17 by 20. This would be Q dash. Your long way would have been Q minus 15 by 100 of Q is equal to Q dash. This 15 by 100 would have become 3 by 20 only, and when you would have worked it, you would have got 17 by 20 Q only. But we want to get here faster and faster, and as comfortably and easy as possible, okay? Here some people will get confused, okay? For example, if I say P is 25% of Q. You should be able to form very quickly P is 1 by 4 of Q. Okay, but here some people habitually will make it either 5 by 4 or 3 by 4, but here there is no problem, there is no increase or decrease. P is 25%, 25% is just 1 by 4, P is 1 by 4 of Q, right? Had the language been P is 25% more than Q, right, then I would have read P is Q, obviously more than Q, so something is getting added, but I don't want the addition form. 25% means 1 by 4, more than that means there is an extra, so think of it as 4 by 4, 1 by 4 is getting added, so Q into 5 by 4. So this would have been your form. So understand the difference between multiplying something by 1 by 4 or 5 by 4 or 3 by 4. When you multiply it by 1 by 4, you mean 25% of that thing or a reduction of 75%. When you multiply it by 5 by 4, you mean 125% of that thing or an increase of 25%. When you multiply it by 3 by 4, you mean 75% of that thing or a reduction of 25%. Why? Because 3 by 4 is 75, but there is a reduction of 1 by 4. So there is a reduction of 25%. Here 1 by 4 is 25%, but there is a reduction of 3 by 4, which is 75%. So many language forms to handle this. Yeah.